Just doing a quick test to see whether I need to change my glasses. I'm a bit worried that my sight is going, so let me just do this quick test. All good. I can wait till next year. Look at that. 32 degrees today. It's way too hot to work. I actually want to go back to this diagram that I finished off in the previous video. I'm not going to go through it entirely, but as a really quick recap, not one database, but a cluster of databases connected to, so there's a switch connected to a network attached storage device. Okay, we have another switch here, which is for inter-cluster communication for these databases, and out here we have a bunch of web servers connected to their own switch here, so they can access the database. So the whole point of this type of model is if you actually want to scale out reads and writes to, because a single database is not good enough, so you actually want to distribute the reads and writes across these databases. This type of model can be used instead of going through something large like a Hadoop cluster. Now, there's another variation of this which I should really show you, because if I don't, my mentors, the guys who I used to work with, will absolutely kill me, and that is where we have a cache in front of these guys. Okay, so here you can have a single database, same storage, backend, single database, but having cache in front of this, and that's a way where you can actually scale up the actual read and writes to the database, but still have a consistent view. So I'm actually going to diagram that for you very quickly. And here we go. Here's an alternative diagram. This is utilizing a product called Oracle Coherence. Seen this before. So we have external storage connected to this database. So it's database, so this is a switch for the external storage. And here we have another switch where we have these application servers. Well, what's so special about these application servers? These servers are running a piece of software, a cluster in memory piece of software called Oracle Coherence. Okay, and what we have here are basically application clients. These are application servers, and very simplistic model. Each of these application servers are running two processes. One called a data node and the other one called an extend node. The data node stores data, so the data will be clustered across these four servers. Again, this box here is a complete server, and E acts as an extend node, or another word for it is a proxy node. So these accept client connections. So in effect, a connection will occur into this extend node here, and then when a client wants to write data into the cluster or read data from the cluster, they do so via these nodes here. Okay, I have to be careful when I say node processes. So let's say processes. So via these processes running, and these are the data processes running, and this node is a server. I have to be careful with my terminology there. Okay, so as an example, this application client here wants to write a piece of data into the cluster. So it makes a connection here, makes a permanent connection to this guy here. Okay, and then when it actually wants to do a write, connect through there, this guy will take it. So basically the write is via a key and a value. So it's always in that form of a key and a value. So the key and value is passed to this extend node here. Okay, the key here is then hashed. So hash code is actually generated, is then modded against the number of extend nodes that we see here. Particular value is generated, and it may literally then say we store the data on this node here. So piece of the primary data will go there, and the backup will be placed on another data node. So let's say here. And that's it. And it's only once the backup is actually being performed that this client will then get notification back that the data has been successfully written. And then the same happens again. So this guy here wants to do a write into the cluster. This guy may in this case be connected to this extend node here. He performs a write via this key value. It may then specify this as the primary node, and then this guy here as the backup node. The primary and backup are always on two separate servers, okay? And it goes on and on and on. So you see this kind of pattern emerging, that you get a mixture of backups. Let's pretend that's the case. You get a mixture of primary data and backup data distributed within the cluster. Okay. Now, why is this good in terms of protecting the database? Because when you actually want to do a write into the system, this performs the write. Primary is placed here. Backups are placed somewhere else. And this, if it's configured as a write through, can write through to the DB and write the data in. Okay. So the great thing about here is that there's only 1, 2, 3, 4 connections to the database. There's only 4 connections, okay? But look how many clients we have. This could be 200, 400, 1,000 clients that we can have here utilizing this system of just 4 coherent servers. And when I say coherent servers, it could be an in-memory type system or database system that has the ability to write itself to write the data here back to some sort of store. So grid gain is another type of technology that we can utilize here. As you can see, there's only 4 connections to the database, and it's written through here to the DB. Okay, awesome system. Now, if these writes are happening really fast, then what you may actually want to configure instead is a window. So this may store writes for about, let's say, 5 seconds, 10 seconds, or 20 seconds. And then when it batches up all those writes, then it flushes it straight into the database. And that's called a write behind. So you can configure these nodes with a write behind type of operation. And the beauty also is with reads. Think about the read case here. Because if you do a read, the data may already be stored, okay, in memory here. As in, it hasn't been flushed from the memory system. So if the data has been written here and you want to do a read, the system may determine that, oh, even though the data exists within the database, but it's also within memory. Okay? Memory is a lot faster, and we can return the data from the cache directly back to the client. So hence, you've actually saved a ton of reads from the database because it may still already reside within the actual in-memory cluster that you see here. Way of how Oracle coherent or in-memory database type system, in front of a database can help to reduce the load on the actual database itself. Okay, so preventing you from scaling this up, even more cores, even more memory to build that beefy database. This can help protect it, and these can be smaller servers, not as beefy as this. It is a complicated system to actually put together. You have to be careful because if this one dies in production, this guy here, you have to make sure you've tuned your system in such a way that these guys can certainly take over. And although the system continues to run, you have to be careful of there. You have to also be careful of not populating your Oracle coherence with too much data, because the danger here is that if you put way too much data in this cluster and it doesn't evict the data fast enough, these guys may start crashing in production. And what you don't want is then your whole cluster to freeze. And data that's potentially here but that has not been written to the database is lost. So you have to be careful about that. So these are the edge cases that you have to be careful. Big data, well, again, we're talking about memory here, right? So even if this server here is configured with 512 gigs of memory, okay, well, think about it. You've got 512 gigs of memory. Part of it is primary data and another part of it is backup data. So you've now, capacity-wise, gone from 512 to 256 gig. But you also need working memory, and you also need memory for data structures. So you may only really have 128 gig of actually capacity within each one of these servers. So times that by 4, you can only hold 512 gigs of data. It's not exactly big data. It's another system. I had to do this. You know, a colleague of mine mentored me on this Oracle coherence system, and I'm sure he'll murder me if I didn't actually show this implementation to you. It's way too hot to do a video today, but I made a vow. I'm going to produce a video today.